Have you ever wondered about the future of computing? What if I told you that the answer lies in the strange and mysterious world of quantum physics? You won't believe how David Deutsch is changing the game with the IBM's Osprey computer realm that David Deutsch dared to explore. Picture this, it's the 1980s, an era of rapid technological advancement. Amidst this whirlwind of innovation, two brilliant minds, David Deutsch and Richard Feynman, envisioned a new kind of computer. A machine that could harness the perplexing and fascinating principles of quantum mechanics to perform computations far beyond the reach of any classical computer. Quantum mechanics, a field that probes the very fundamentals of our universe, is nothing short of mind-boggling. Its two key principles, superposition and entanglement, defy the rules of classical physics that we're all familiar with. Superposition allows quantum bits or qubits, the basic units of information in a quantum computer, to exist in multiple states at once, rather than being limited to the ones and zeros of classical bits. On the other hand, entanglement creates mysterious links between qubits, such that the state of one can instantly affect the state of another, no matter the distance between them. These principles, as strange as they may seem, form the bedrock of quantum computing. The audacious proposition from Deutsch and Feynman sparked a global race to build the first quantum computer. A race not just for technological supremacy, but for a deeper understanding of the very fabric of reality. Their idea was not without its skeptics. Many thought it was too outlandish, too absurd. But as we've learned time and again, today's absurdity can be tomorrow's reality. Despite the skepticism, the seeds of quantum computing were sown, and over the ensuing decades, they would germinate, sprout and grow into a field of study that stands poised to redefine our understanding of computation. And so, with the birth of this audacious idea, began a journey to harness the power of quantum mechanics to revolutionize computing. A journey that we continue to traverse as we stand on the brink of what could be the dawn of a new era in computing, a quantum era. Thus began a journey to harness the power of quantum mechanics to revolutionize computing. The first steps towards actual quantum computers were taken in the late 1990s. This was a time when the world was still grappling with the potential of classical computing, yet a handful of visionary scientists and engineers were already looking beyond the Silicon horizon. The creation of the first rudimentary quantum computers was akin to the Wright brothers' first powered flight. Brief, fraught with difficulty, yet undeniably groundbreaking. A milestone that stands out is IBM's creation of the first 2-qubit quantum computer in 1998. Just as classical computers use bits, quantum computers use quantum bits or qubits. Unlike traditional bits, which can be either 0 or 1, qubits can be both at the same time, thanks to a quantum quirk known as superposition. Yet, creating a machine that could harness such an elusive and counterintuitive phenomenon was no mean feat. These early quantum computers were crude and error-prone, and the challenges they faced were numerous and significant. One of the most prominent was the issue of quantum decoherence. In a nutshell, quantum decoherence is the loss of quantum behavior, or quantum information. It's a bit like attempting to maintain a delicate tune on a violin while in the middle of a rock concert. The cacophony of the surroundings makes it nearly impossible to keep the tune. Similarly, quantum systems are extremely sensitive to their environments, and even the slightest disturbance can cause the qubits to lose their quantum behavior, leading to computational errors. Scientists had to devise ways to isolate their quantum systems from the outside world, a task easier said than done. They experimented with different materials and temperatures, fine-tuning their approach with each new iteration. Despite these challenges, the early pioneers of quantum computing persevered. Through their tireless efforts and innovative thinking, they laid the foundation for the quantum computers we know today. These machines, while still in their infancy, promised to revolutionize everything from drug discovery to climate modeling. And it all started with those first few tentative steps in the late 1990s. These pioneering efforts laid the groundwork for the quantum computers of today. Fast forward to today, and quantum computers have made remarkable strides. The field of quantum computing has evolved into a vibrant playground where the world's biggest tech giants are vying for supremacy. Among the major players, Google, IBM, and D-Wave Systems are leading the pack. Google's Quantum AI Lab is pushing the envelope in building quantum processors and developing novel quantum algorithms. IBM, on the other hand, is not just building quantum computers, but also making them accessible to the public through its cloud-based quantum computing service, IBM Quantum Experience. Then there's D-Wave Systems, a company that has veered off the beaten path with its approach to quantum computing, focusing on quantum annealing. a specific type of quantum computing. These quantum computers are not just theoretical constructs but are demonstrating practical applications. They're flexing their computational muscles in fields that have long stumped classical computers. In cryptography, quantum computers could potentially crack codes and ciphers that would take a classical computer an age to decipher. This is due to the inherent properties of quantum bits or qubits which, unlike classical bits, can exist in multiple states at once, vastly increasing their computational power. Another exciting application is in the field of drug discovery. Identifying new drugs is a complex problem that involves mapping and predicting how molecules will interact. With their ability to process vast amounts of information simultaneously, quantum computers could revolutionize this process, potentially leading to breakthroughs in medicine. And then there's climate modeling. Understanding our planet's climate system is a mammoth task with countless variables to consider. Quantum computers, with their superior processing power, could help us create more accurate climate models, leading to better predictions and more effective interventions. While quantum computing has come a long way, there's still much to explore. The quantum era is just beginning, and as we continue to unlock its potential, who knows what incredible discoveries lie ahead. However, the path to fully functional quantum computers is riddled with challenges. Quantum computing is a field that pushes the boundaries of our understanding of both computing and physics. But as with any pioneering endeavor, there are significant hurdles to overcome. One of the key challenges in quantum computing is maintaining quantum coherence. This refers to the delicate state in which quantum bits or qubits exist. Unlike classical bits, which are either 0 or 1, qubits can exist in a state of superposition, where they are both 0 and 1 at the same time. However, this state is incredibly fragile, easily disturbed by environmental factors like temperature and electromagnetic radiation. Keeping qubits in a coherent state long enough to perform calculations is a significant challenge. Then there's the issue of error correction. In classical computing, if a bit flips from 0 to 1 or vice versa, it's easy to detect and correct. But in quantum computing, errors can occur in a multitude of ways thanks to the complex state of qubits. Developing error correction methods for quantum computing is an ongoing area of research, and a crucial one, as even a single error can derail a quantum calculation. Scaling up quantum systems is another important challenge. Today's quantum computers only have a few dozen qubits at most, but to really harness the power of quantum computing, we'll need machines with thousands or even millions of qubits. This is a formidable task, requiring advances in everything from materials, science to engineering. In spite of these challenges, research is ongoing to address them. Scientists worldwide are working on innovative solutions, from developing new materials that can better maintain quantum coherence, to creating novel error correction algorithms, to designing scalable quantum architectures. The road to full-fledged quantum computers is steep and fraught with difficulties, but the potential rewards are immense. These challenges are daunting, but they're not insurmountable. Quantum computing is a field in motion, a testament to human ingenuity and the pursuit of knowledge. And as we continue to push forward, who knows what incredible breakthroughs lie just around the corner. As we look towards the future, the potential of quantum computing is vast and exciting. This revolutionary technology, still in its infancy, is poised to change the world as we know it. Imagine a world where artificial intelligence is supercharged by the power of quantum computing. Quantum computers, with their ability to process vast amounts of data simultaneously, could give AI the boost it needs to truly mimic human thought processes. We're talking about AI that can learn, adapt, and respond in real time, making it more intuitive and intelligent than ever before. And what about cryptography? The quantum world could turn it on its head. Today's encryption methods, used to keep our online information secure, could become obsolete. Quantum computers could crack codes in seconds that would take today's most powerful supercomputers millions of years. But it's not all doom and gloom. The same power could be harnessed to create unbreakable encryption systems, paving the way for a safer and more secure digital world. In the field of medicine, quantum computing could be a game changer. Imagine being able to model complex molecular structures or simulate the human body at a quantum level. This could lead to breakthroughs in drug discovery and personalized medicine, potentially saving millions of lives. The excitement doesn't stop there. Quantum computing could even lead to the creation of a true quantum internet. A quantum internet would allow for instantaneous communication, regardless of distance, and provide unprecedented levels of security. It's a concept straight out of science fiction, But with the advances in quantum computing, it's becoming more science than fiction. The future of computing may well be quantum, and it's a future full of promise. Quantum computing is still a field in its early days, but its potential to revolutionize our world is undeniable. The quantum era is coming, and it's set to change everything. So, what have we learned about the journey of quantum computing? In the span of just a few minutes, we've traversed a journey that began at the dawn of quantum computing. Born out of the minds of visionary scientists, this technology was conceived as a radical departure from classical computing. The birth of quantum computing marked a significant shift, a move from traditional bits to quantum bits, or qubits, which exist in a state of superposition, allowing them to be both 0 and 1 at the same time. As we moved forward, we explored the first quantum computers. These machines, though primitive by today's standards, were monumental in their time. They laid the groundwork for what was to come, paving the way for a new generation of quantum machines. Then we ventured into the present day, a time where quantum computing is no longer a distant concept, but a reality. Today, quantum computers are being used to solve complex problems in various fields, from cryptography to drug discovery, showcasing the immense potential of this technology. Yet, despite its promise, we also acknowledge the challenges that lie ahead. Quantum computing is still in its infancy, grappling with issues of stability, scalability, and error correction. These hurdles are substantial, but they are not insurmountable. With continued research and development, we can overcome them. And finally, we gazed into the future. A future that's brimming with possibilities. The future of quantum computing holds promise for advancements in artificial intelligence, optimization, and even the potential to simulate the universe itself. As we step into the quantum age, one thing is certain: the future of computing is anything but ordinary. Yes, the path ahead is filled with challenges, but it's also filled with limitless potential. The quantum revolution is upon us, and it's going to change the way we think about computing, and perhaps the world itself. As we step into the quantum age, one thing is certain: the future of computing is anything but ordinary.